In this problem, we're told the position of the front bumper of a test car under a microprocessor control is given by x of t equals 2.17 meters plus 4.8 meters squared t squared minus 0.1 meters per seconds to the 6th power times t to the 6th. And then A, find its position and acceleration at the instance when the car has 0 velocity. And B, draw the x of t, vx of t, and ax of t graphs for the motion of the bumper between t equals 0 and t equals 2 seconds. So what we're given here is some position function, right? X of t equals 2.17 plus 4.8 t squared minus 0.1 t to the 6th. And so let's just go ahead and start with A. So A, find its position and acceleration at the instance when the car has 0 velocity. So we need to find when the car has 0 velocity if we want to find its position and acceleration then. So the first thing we have to do is find the velocity function and then the acceleration function. So we're starting by finding v of t, and the way you do that is just by taking the derivative of your function. So the derivative of 2.17 is 0. So we have 0, I'm not going to write that though, plus 4.8 t squared, so this is just going to become 9.6 t, because you just move it down in minus 1. And then minus, this is going to be 0.6, and then t to the 5th. So we've got v of t, and now we're going to find a of t, because we need that too. This is going to become 9.6, because the t just goes away. And then minus, this is going to become 3t to the 4th. So now we've got v of t and a of t. So we need to find a of t and x of t when velocity is 0. So we're going to find the time value when velocity is 0. And then we can plug it into these functions and find, this is the position function. So it'll give the position when t is, or the t value for when v equals 0, and same for this. So we're going to solve this for 0 now. So we want to say 9.6t minus 0.6t to the 5th. And so basically we can factor out a t here. So t times 9.6 minus 9.6 minus 0.6t to the 4. And so this is just going to be equal to 0. And so keep in mind, since we can just set t equals 0, so obviously at t equals 0 seconds, the velocity is 0, because we can plug in 0 here for t. And then the way we can find the other value is, or I think the best way is just by taking your calculator. So take your calculator, hopefully you have a graphing one. And so you're just going to plug in this function into the graphing calculator. So it's going to be 9.6x and then minus 0.6x to the 5th. And so you're going to go ahead and graph this. And what you're going to find is that when it crosses through the x-axis is when its velocity is 0. And so basically, you can see that it crosses through the x-axis. Well, it's going to cross through multiple times, but every time before or negative doesn't make sense because t can't be negative because it's time. There's no such thing as negative time. But you'll see it cross through at 0 and then t equals 2 seconds. So basically, these are the two values or time values when the velocity is 0. So now we've got both of those. All we have to do is plug into the position and the acceleration functions, and we'll be able to find what we're trying to find, right? The position and acceleration when the car has 0 velocity. So let's start with t equals 0. So t equals 0, x of 0. This is going to be equal to 2.17 because 0 into this and 0 into this. These are going to cancel. So 2.17 meters, that's 1. And then we're going to do a of 0. So this is just going to be 9.6 minus, and then this is going to be 0. So just 9.6. Units are meters per second squared because it's acceleration. Now let's do t equals 2 seconds because that's the other time. We'll do x of 2. So it's going to be equal to 2.17 plus 4.8 times 2 squared minus 0.1 times 2 to the 6th. And so when you go ahead and do this, you're going to find that it's equal to about 15 meters. It's going to be pretty close, so I'm just going to round. So 15 meters. Now let's do acceleration at 2 seconds. So 9.6 minus, using this function, 3 times 2 to the 4th. And so when you go ahead and do this, you're going to find this equals about minus 38.4 units again for acceleration, meters per second squared. So we're going to be slowing down in this. So now we have basically, these are going to be your answers to A, right? So these are your answers to A. So 2.17 meters, 9.6 meters per second squared. That's when 0, and then it's also, velocity is also 0 at 2 seconds. So 15 meters and then minus 38.4 meters per second squared. Now let's move on to B. And so B, we're just going to be drawing some graphs. And so the way you want to do this, right, it says draw x of t, vx of t, and ax of t. What you could do is just plug in points along a graph, but you could also just use your graphing calculator. So let's just start with x of t. And so I'm just going to give you the rough sketch of what it looks like. If you really want to see the best numbers, just plug it into your calculator. So it's going to look something like this. This is about 15 right here. And then this is 2, because obviously we're going from 0 to 2 is what they want. And so now let's do v of t. So v of t is going to look like, this is 10, this will be 2. It's going to look something like, imagine this is 0, so like this. It's not the best graph, but something like that. And then a of t, let's do this. So a of t is going to look like, this is 10, and then let's just say this is 2. It's going to look something like this. So kind of something like that. Keep in mind it's going to start at 10. And so yeah, this is going to be your position, this is going to be your velocity, and this is your acceleration. So these are going to be your graphs or your answer to B. Keep in mind these were your answers to A. And yeah, so these are your answers, and hopefully you found this useful.